Hi students, today we are going to study about the programmable logic devices. Okay, so these logic devices will take a binary input and will give a binary outputs. So these are used for mainly controlling the peripherals and controlling the devices, etc. Okay, so a logic device provide specific functions. Okay, so these functions included device to device interfacing, data communication, signal processing, data display, timing and control operations. Okay, and almost every functions that a system can perform. Okay, it can be performed by programmable logic devices. Okay, so these programmable logic devices are classified into two categories. One is fixed and programmable. Okay, fixed means a fixed logic circuit will be there and it will be a permanent one. Okay, so we cannot modify the program or we cannot do anything. So once it is manufactured means it cannot be changed. Okay, so that is fixed type of logic devices. Okay, so the program cannot be changed and we cannot use it for any other applications. Okay, and programmable logic devices that will offer wide range of logic capacity and features. Okay, then it has high speed. Okay, and voltage characteristics also very high. Okay, so this is a good type of what programmable logic device. So programmable logic devices offers wide range of logic capacity because we can write any type of logic programs to the PLDs. Okay, and it has good capacity. Okay, and the features are good and it has high speed. Okay, and the voltage characteristics are good. Okay, and these devices can be reconfigured, okay, to perform any number of functions at any time. Okay, so we can write a program and we can make it function as any type of device that we require. Okay, so that is the peculiarity of what programmable logic devices. So in order to design this we need some inexpensive software tools. Okay, so first we have to design or develop a software, then we have to simulate, then we have to test the logic design. Okay, then only we can implement it into a system. So this design can be quickly added to the PLDs or programmable logic devices. Okay, and it can be immediately tested using a live circuit. Okay, so these are the peculiarities of programmable logic devices. Okay, so these PLDs are based on rewritable memory technology. Okay, rewritable memory technology means we can write any number of programs, we can change the program and we can write the program. That's why the name programmable logic device. Okay, so it can be reprogrammed and we can assign new programs into the programmable logic devices. Okay, so these programmable logic devices are again classified into two broad categories, that is complex programmable logic devices and FPGA, field programmable gate arrays. Okay, so one is complex programmable logic devices and second one is field programmable gate array. So these are the two major classifications of programmable logic devices. So we will study FPGA. So what is FPGA? So FPGA is an integrated circuit. Okay, so that is designed to be configured by the designer. Okay, after manufacturing. So it can be configured by the designer or the programmer after manufacturing also it is possible. Okay, so this FPGA offers high amount of logic density. Okay, so many logic applications we can incorporate inside this FPGA. Okay, so it provides many number of features and the performance is very high. Okay, so the logic gate is medium to high density. The gates that are present inside this FPGA is medium to high density. So what is the number of gates that are present? 1K to 500K system gates are present inside a FPGA. Okay, so that is another one peculiarity of FPGA. Okay, so in advanced FPGAs, that is developed by IBM powered PC that are present inside the IBM powered. So it consists of a built-in hardwired processor. Okay, so a built-in hardwired processor will be present inside this FPGA. Okay, and it consists of substantial amount of memory. The required amount of memory is also present inside this FPGA, and there will be a clock management system. A timing and control unit will be there. Okay, and it will support the latest signaling technologies. The latest signaling technologies are supported by this latest FPGA that is present in IBM powered PC. Okay, so the main advantage is the number of gates that are present. 1K to 500K gates are present inside this FPGA. So if you look into this circuit, okay, so this is one part of the circuit. So these advanced FPGA devices offer features such as built-in hardwired processor, okay, good amount of memory, clock management, timing and controller. Then it will support all the device to device signaling also is supported. Okay, so the application of this FPGA is in data processing and data storage. Okay, in instrumentation it is used. Okay, in telecommunication it is used. Okay, for switching applications it is used. Okay, and digital signal processing also we will use this programmable logic devices. So this programmable logic device consists of input output block. Okay, so this input output block we can change the program of this input output block. So it is the block that is used for interfacing with the external devices. Okay, so that is a programmable block and we will include our program in this input output block. And inside this FPGA again we have a control block. So this control block will provide the timing signals, control signals, etc. So based on this control signals only this FPGA will work. Okay, so these are the two types of blocks that are present inside this programmable logic devices. So next we will look into this CPLD. Okay, so CPLD means a complex programmable logic device. Okay, so this is a complex programmable logic device and it consists of so many small blocks. Okay, so we have previously we have a control block and a input output block. Okay, so here inside this CPLD we have small units like a combination of a control block and an input output block. Okay, and all these blocks are interconnected using some buses or interconnection wires. Okay, so it includes the configuration or the architectural features of PALs and FPGAs. Okay, so both the power of both type of devices can be incorporated into this CPLD. Okay, the main advantage of the CPLD is the number of gates. Okay, so the number of gates that are present inside this CPLDs are 10,000 gates. Okay, so the timing characteristics of this CPLD, okay, it is very predictable, and it can be used for what ideal, uh, it can be used for critical control applications. Okay, so that is another advantage of this CPLD. So generally, what is the advantages of these PLDs? Okay, so these PLD devices that will provide the customer more flexibility during the design cycle. Okay, that is one advantage. Okay, so another advantage is PLDs do not require long lead time for prototype to production. Okay, so if the prototype is produced, then immediately we can go for the production process. Okay, so it will be already programmed and it will be ready for the shipment. Okay, then PLDs do not require customers to pay non-recurring engineering charges. Okay, and it does not require what expensive mask set also, it is not required. Okay, so this PLDs will allow, okay, the number of the embedded systems that can be designed and it can be developed. Okay, so it will control the customer to control the inventory, it will allow the customer to control the inventory. Okay, so that is also another one advantage of this PLDs. Okay, so these PLDs are again programmable, we can write any number of programs into these PLDs, and then the customer can also program the PLD. Okay, because there is a flash memory that is present inside the PLD. Okay, so the manufacturer can add new features. Okay, so he can release a new firmware, and he can make it work. Okay, after production also he can change the program and he can update the software and make it work. Okay, so these are the advantages of PLDs. Okay, so thank you for listening to this lecture.